Welcome back to the deep dive. We're here again, ready to take that big stack of sources, all the research papers, the notes you've shared, and really boil it all down. We want to get to the essential stuff, the actionable knowledge, the insights that actually matter day to day. Today, we're setting out on a mission. It's centered around a nutrient that, well, it feels super familiar, right? Vitamin D. We think sunshine. We think bone health. But scientifically, it keeps throwing curveballs. We're all aiming for what doctors call healthy aging. It's not just about living longer, is it? It's about extending those years where we're active, mentally sharp, independent, quality of life deep into those later decades. That's the real prize. And your research, it really zeroes in on this sunshine vitamin as a potential, maybe even a powerful ally in that whole quest. But to really get it, we have to look past the label. One of the things that jumped out at me from your notes was this fundamental identity change.
That's absolutely the essential starting point.
Yeah.
Our mission today is to do a proper deep dive into vitamin D and, crucially, understand why the sources insist on calling it not just a vitamin, but a prohormone.
A prohormone.
Right, and that one word, it completely transforms how we look at its impact. It lifts it from being, just another supplement to a really powerful signaling molecule, one that works across pretty much every major system in the body.
Wow. So definitely not just about bones anymore.
Oh, far beyond preventing rickets, yes. We want to unpack how this molecule might actually mitigate age-related decline, how it influences everything from, say, muscle strength right through to neurocognitive function.
Okay, so the big question framing this whole deep dive is, how does this molecule, something our body makes with just a bit of sun, how does it get this power to literally interact with our DNA, to act almost like a manager for our aging process? We really need to unpack that mechanism because that feels like where the real story begins. Right. Let's kick off with that identity shift you highlighted. Why is it so critical to define vitamin D not just as a vitamin, but specifically as a prohormone? And what makes it different, structurally speaking?
Great place to start. So the term vitamin usually implies something essential that our body can't make, so we have to eat it. But our bodies can produce vitamin D, specifically D3, that's cholecalciferol, when our skin gets hit by UVB sunlight.
Ah, okay, so we make the raw ingredient.
Exactly. Then, once it's made or we consume it, it goes through two chemical steps called hydroxylation, first in the liver, then the kidneys. And that converts it into its active hormonal form, which is called calcitriol. And that form acts just like a steroid hormone. That's why prohormone is the accurate term. It's also fat-soluble, which is key for understanding how it gets absorbed and also how it's stored. It builds up in body fat.
Got it. So it's like an ingredient our body upgrades into a powerful executive hormone. Okay. How does this hormone then manage to exert such wide-ranging control? You mentioned a specific mechanism underpinning its power.
This is the absolute core of it. The active form calcitriol, it doesn't just sort of float around hoping for the best. It's designed to bind to a very specific protein inside our cells, the vitamin D receptor, or VDR.
EDR.
Now, the power comes from where this VDR is located, and the answer is pretty much everywhere. It's found in the nucleus, the control center of virtually all cells and tissues. Skin, gut, pancreas, muscle, brain, immune cells, you name it.
Seriously. Almost all cells have this receptor.
Almost all. And when calcitriol clicks into that VDR, the whole complex, the hormone and the receptor together, travels to specific spots on our DNA. These spots are called vitamin D response elements, or VDREs.
Okay, VDREs on the DNA.
Think of the VDR calcitriol complex as a key. And the VDRE is the lock on your DNA. When the key turns, it acts as a molecular switch. It can activate or deactivate hundreds, maybe thousands, of specific genes. And that control over gene expression is what gives vitamin D its incredible systemic reach. It's literally dictating how cells behave, how they grow, what they become.
That is staggering. I mean, a nutrient having keys to the DNA library in almost every cell. It really is a systemic maestro, not just a local player for bones. And while its classic role is famous, the sources you sent highlight 5 key areas where this genetic switching is vital. Let's start with the most well-known one.
Yes, the classic. Calcium and phosphate homeostasis. This is absolutely fundamental for life, non-negotiable. Calcitriol, the active D, massively enhances how well our intestines absorb calcium and phosphate from our food into our bloodstream.
Right, the building blocks for bone.
Exactly. That's the primary way we get the raw materials. But it's not just about building and maintaining strong bones and teeth. Keeping the calcium levels in our blood within a very tight range is critical for, well, everything. Nerve signals, muscle contractions, basic cell communication throughout the body.
And if D is low,
If D is low, the body doesn't absorb enough calcium. So to keep blood levels stable, it starts pulling calcium out of the bones. That leads directly to weakened bones, osteomalacia in adults, rickets in kids, and contributes significantly to osteoporosis later in life.
okay, that's the foundation. But you said VDRs are everywhere, including soft tissues. So moving beyond structure, how does it influence cellular growth and differentiation? This sounds more directly related to aging and repair.
Absolutely. We find active VDRs in skin cells, immune cells, muscle cells, neurons, the list goes on. In these tissues, vitamin D influences cell proliferation. That's how fast cells divide and reproduce. It also guides differentiation, which is how cells mature and specialize to do their specific jobs. Think of stem cells becoming specific types of tissue, and critically, it plays a role in apoptosis or programmed cell death.
Cell suicide, essentially. Why is that important?
It's vital. Apoptosis ensures that old, damaged, or potentially cancerous cells are safely removed before they caused problems. So, by regulating growth, specialization, and cleanup, vitamin D is crucial for ongoing tissue repair, renewal, and potentially preventing runaway cell growth, like in cancer.
Okay, that makes sense. Now, the third role you mentioned, and this feels incredibly relevant for healthy aging, is its job in immune system modulation.
Yes, this is a huge area of research. D acts as a really important regulator of our immune response. It affects both sides of the system, the innate immunity, that's our first general defense line, and the adaptive immunity, which is the more targeted, learned response involving antibodies and memory cells.
How does it regulate? Does it boost it or calm it down?
Both, actually, which is what makes it so smart. It can enhance the function of key defensive cells, like T cells and macrophages, basically helping our immune soldiers fight infections more effectively.
Okay, boost the good guys.
But simultaneously, and this is where its anti-aging potential really comes in, it helps suppress excessive inflammatory responses. It prevents the immune system from going overboard and causing chronic inflammation or attacking healthy tissues like in autoimmune diseases. It's a balancer.
A balancer. I like that. Okay, fourth, underpinning physical independence through muscle function.
This links directly to preventing frailty and maintaining mobility as we age. Adequate vitamin D is essential for muscle strength and overall performance.
How does it work in the muscle itself?
Mechanistically, it influences how calcium is transported and handled within the muscle cells, specifically in a structure called the sarcoplasmic reticulum. Since calcium release is the direct trigger for muscle contraction, well, D is involved in the efficiency and power of literally every move you make. Low D often means weaker muscles.
Makes sense. And finally, number five, a role that's gotten a ton of attention recently, cardiovascular health.
Yeah, this brings us right back to that systemic gene control. There's growing evidence suggesting D is involved in keeping our blood vessels healthy.
How so?
Well, for instance, VDRs are found in the smooth muscle cells lining blood vessels and in kidney cells. When activated by calcitriol, they can modulate genes controlling the production of renin.
Renin, that's involved in blood pressure, right?
Exactly. Renin is a key enzyme in the system that regulates blood pressure. By helping to lower renin production, D might help relax blood vessels and lower pressure. There's also evidence it might help reduce arterial stiffness, which is a classic sign of aging in our circulatory system. So potentially very important for heart health as we get older.
Okay, those five roles alone paint a picture of a molecule that's just intrinsically tied to how well we function systemically. Now let's shift gears slightly. Let's look at where the science is really pushing the boundaries. The areas where research is showing promising, though maybe not totally definitive yet, results for specific anti-aging benefits.
I think probably the area with the highest stakes, certainly the one getting a lot of attention, is cognitive decline and neuroprotection. We have a pretty substantial body of observational studies, and they show a consistent and, frankly, quite concerning link. Lower vitamin D levels seem correlated with a higher risk of cognitive impairment.
Impairment like memory loss.
Yes, ranging from mild cognitive impairment all the way to more severe conditions like vascular dementia and even Alzheimer's disease.
Okay, that's a strong correlation. But why? What's the potential mechanism?
Well, the sources point to several very plausible biological reasons, mostly seen in lab studies so far. First, we know D receptors, those VDRs, are present throughout the brain. They're particularly dense in areas critical for memory and learning, like the hippocampus.
Okay, so the hardware is there in the brain.
Exactly. Second, vitamin D has shown in lab settings that it can actively protect neurons from oxidative stress and damage that's a major factor in age-related brain decline. Third, it seems to play a role in reducing neuroinflammation within the brain itself. Think of it like calming down that low-grade inflammaging, specifically in the brain tissue.
And I remember seeing something specific about Alzheimer's hallmarks.
Correct. Some lab studies suggest vitamin D might help the brain clear out amyloid beta plaques.
The sticky stuff associated with Alzheimer's.
The very same. Now, the role of amyloid is still debated, but if D helps the brain's cleanup crew, the glial cells, work better, it could potentially mitigate one of the defining features of the disease.
So compelling biological reasons.
But we absolutely have to stress we don't yet have large-scale clinical trials definitively proving that taking vitamin D supplements prevents Alzheimer's in humans. The biological plausibility is strong, but the final proof isn't in yet.
Okay, important distinction. Now, moving from the mind to the body, the most visible aspect of aging for many is the decline in physical independence, frailty, and falls. This seems to link right back to the bone and muscle roles.
Yeah.
Yeah, losing physical independence. That's often what people fear most about getting older. It really marks that shift from thriving to feeling, well, frail. So by shoring up bone density and helping muscles contract efficiently, vitamin D directly tackles the risk of frailty, falls, and those devastating fractures in older adults.
Absolutely.
Your sources mentioned specific clinical trials looking at falls.
Yes. There have been quite a few. And several have shown that vitamin D supplementation, especially in people who were deficient to begin with, can significantly improve lower limb muscle strength and, crucially, reduce the actual number of falls. That's a direct, measurable impact on safety and quality of life. It keeps people on their feet and out of the hospital.
A very tangible benefit. And this physical resilience is boosted by its role in our overall defense system, right? We touched on the immune system, but let's talk specifically about immune senescence and chronic disease.
Right. Immune senescence is a really key concept in the biology of aging, in gerontology. It basically describes how our immune system naturally gets older and less effective over time. We produce fewer fresh, naive immune cells, and we accumulate more dysfunctional pro-inflammatory ones.
Making us more vulnerable.
Exactly. It makes older adults more susceptible to infections, things like flu or pneumonia. It also means vaccines might not work as well, and it contributes to that chronic inflammation background.
So how might vitamin D help with this immune aging?
Because it acts as that balancer or immunomodulator we talked about, it's being seriously investigated for its potential to mitigate this decline. By helping key immune cells function properly while also dialing down chronic inflammation, the idea is that D could help maintain a more youthful, effective immune surveillance system for longer. Slowing down immune aging improves overall resilience.
And the sources were quite clear about linking low D status in older people to a whole range of chronic conditions.
That's right. Deficiency or insufficiency has been correlated, again, mostly in observational studies, with a higher risk for several major age-related diseases, things like cardiovascular disease, certain cancers, particularly colorectal, but also prostate and breast type 2 diabetes, and autoimmune disorders like rheumatoid arthritis or MS.
And the common thread seems to be.
It often seems to come back to two of D's core functions we discussed. Its ability to regulate cell growth and proliferation, which is relevant for cancer, and its powerful anti-inflammatory effects, which are relevant for almost everything else on that list.
So while we need to be careful about cause and effect, its fingerprints are kind of all over these major diseases of aging.
Its pervasive role certainly makes it a very attractive target for preventive health strategies. If we can optimize D status, maybe we can nudge the needle on some of these complex conditions.
This feels like the perfect transition to what, reading through your sources, seems like the most crucial concept for D's role in healthy aging. Inflammaging. If vitamin D is this biological ally against aging, its main weapon seems to be its ability to manage our internal environment, specifically this chronic inflammation. Let's really drill down into this term, inflammaging.
Yes, chronic low-grade inflammation, or inflammaging as it's often called, is arguably one of the single biggest underlying drivers of most age-related chronic diseases. It's not like the acute inflammation you get with a cut, red hot, swollen. This is different. It's a silent, persistent, low-level simmering of inflammation throughout the body. It never really shuts off.
What drives it? Why does it happen as we age?
It's driven by a combination of things accumulating over time. Cellular damage, the buildup of senescent cells, those are old cells that refuse to die and just spew out inflammatory signals, and also a generally tired, dysregulated immune system.
And the simmering inflammation connects all those diseases we mentioned.
It seems to be the common soil from which many of them grow. Neurodegeneration like Alzheimer's, cardiovascular disease, arthritis, muscle wasting, even some cancers, they all have chronic inflammation as a major component. It basically acts like an accelerant for the biological aging process.
Okay, it's the enemy. So how does vitamin D step in to fight it? How does it turn down that inflammatory volume?
It works on multiple levels, and it all stems back to that VDR binding and gene regulation. First, active vitamin D directly suppresses the production of pro-inflammatory cytokines. These are the chemical messengers that yell, inflammation, more inflammation.
Right.
Things like TNF-alpha, interleukin-6. D tells the cells to make less of these signals.
So it quiets the alarm bells.
Exactly. And second, it simultaneously increases the production of anti-inflammatory compounds. So it's a two-pronged attack. Reduce the go signals, increase the stop signals.
Very strategic.
By modulating these inflammatory pathways in such a balanced way, D helps restore equilibrium. It stops the immune system from being constantly hyperreactive and damaging healthy tissues over the long haul. And that's the protective effect we see across so many conditions. When we talk about D helping the heart or the brain or the joints, a huge part of that is likely its ability to combat inflammaging in those specific tissues.
It really sounds like the closest thing we have to a systemic calm down signal for the body's internal aging process. And this anti-inflammatory role works hand in glove with the structural benefits, doesn't it?
Yeah, we really can't stress this enough. Fighting inflammaging and maintaining physical structure, they're two sides of the same coin for healthy aging. Preserving bone and muscle health with adequate D isn't just about preventing falls or fractures, important as that is. It's about maintaining the actual scaffolding that allows for a mobile, independent life.
When you combine D's power to reduce that systemic low-grade inflammation with its direct role in making sure calcium gets absorbed properly and muscles can rebuild themselves, well, that's a potent combination for staying strong. You can't fight inflammaging well if your basic structure is crumbling.
Absolutely right. And that loop feeds right back into protecting the brain, highlighting those neuroprotective mechanisms again. We know inflammation is toxic to brain cells. D's ability to regulate the brain's own immune cells, the microglia, seems key here. The sources also mention potential antioxidant effects from vitamin D, helping to neutralize those damaging free radicals that accumulate with age, especially in energy-hungry brain tissue.
It's like a shield.
A shield, yes. And it might even support neural repair processes. So by providing this multi-level protection, antioxidant, anti-inflammatory, potentially supporting repair, vitamin D offers a really robust biological case for helping preserve cognitive function and slowing down that mental decline many people fear.
Okay, the picture emerging is incredibly compelling. D as a central regulator, tackling the core mechanism of biological aging, chronic inflammation, while also propping up the physical structures we need to stay active and independent. Sounds almost too good to be true. Which naturally brings us to the crucial need for scientific caution and understanding the limitations.
Right.
As exciting as all this science is, we absolutely have to inject a healthy dose of caution and scientific rigor here. We can't let the potential blind us to what we don't know or what the current limitations are. It's so important not to view vitamin D as some kind of magic bullet or to mistake these correlations we see for definite causes.
This segment is absolutely vital for anyone listening. The enthusiasm needs to be grounded in the current scientific reality. And the first, maybe the most important limitation is stated very clearly in the sources. There's currently no scientific evidence, zero, that vitamin D can actually halt or reverse the fundamental biological processes of aging itself.
Meaning things like,
Things like our telomeres getting shorter with each cell division, or the accumulation of DNA damage over decades. Aging is incredibly complex, driven by dozens of interacting factors. Vitamin D appears to mitigate some aspects of age-related decline, but it is absolutely not an anti-aging time machine. It doesn't stop the clock.
okay, crucial point. It manages decline, doesn't reverse aging itself. And that leads right into the big challenge in all nutrition research, but especially here, correlation versus causation.
This point cannot be hammered home enough. Many of those really impressive links we've discussed, like low D levels being associated with higher rates of heart disease or cognitive decline, are based primarily on observational studies.
Meaning we just observe a pattern.
Exactly. We look at large groups of people, measure their D levels, and see who gets sick over time. We see a connection, a correlation. But that absolutely does not prove that the low vitamin D caused the illness.
Okay, let's dig into that a bit. Because those observational links, say with Alzheimer's, they look pretty strong, pretty scary. How do researchers try to tease apart whether low D is a symptom versus a cause? Like, is low D just a sign that someone is already frail and maybe not getting outside or eating well?
That's the million-dollar question. The only way to really establish causation convincingly is through large-scale, long-term, randomized controlled trials, RCTs.
The gold standard.
The gold standard. You take thousands of people, randomly assign half to get vitamin D supplements, half to get a placebo, and then you follow them for years, sometimes many years, to see if the D group has significantly lower rates of developing the disease, be it heart attacks, cancer, dementia, whatever.
Now, what have those big RCTs shown so far for D?
Well, some RCTs have confirmed benefits, particularly for bone health and reducing falls, especially in deficient older adults. That seems pretty solid. However, many of the really large, expensive trials designed to show that D-supplementation could prevent major events like cardiovascular disease or cancer have produced, frankly, mixed or often disappointing results. No clear preventative effect across the board.
So what does that suggest?
It suggests a few possibilities. Maybe D primarily benefits those who are truly deficient to start with, bringing them back up to a necessary baseline. Or it could mean that in many cases, low D isn't the root cause of the disease, but rather a marker or a consequence of other underlying problems like poor overall diet, lack of exercise, obesity, or existing chronic illness. Those might be the real drivers, and the low D just goes along for the ride.
So the correlation is real, but the causation is still murky for many of these conditions.
Very murky. We have to maintain that critical distinction. Assuming causation where it hasn't been proven is a big pitfall.
Okay. Another major gray area is figuring out the target. The ambiguity of optimal level seems to be a huge source of confusion for everyone. What is the right level?
It is a massive ongoing debate in the scientific and medical communities. We measure D levels in the blood, usually as 25-hydroxyvitamin D, and the units are typically nanograms per milliliter, NGML, or nanomoles per liter, NML.
And what numbers should people aim for?
Well, there's broad agreement that levels below 20 NGML, or certainly below 12 NGML, constitute deficiency and definitely need treatment. That's pretty clear for bone health.
But above that?
Above that, it gets fuzzy. The big debate is really between, say, 20 NGML and maybe 50 NGML. You have major bodies offering different perspectives. The U.S. Institute of Medicine, IOM, Focusing mainly on bone health from RCT data suggests sufficiency is achieved at 20 ng/NPL. However, other groups, like the Endocrine Society, often recommend aiming higher, maybe closer to 30, 40, or even up to 60 ng/ml.
Why the higher targets?
Their reasoning is based more on optimizing those non-skeletal pleiotropic effects we talked about, immune function, inflammation control, potentially cardiovascular benefits, which might require higher baseline levels, according to some observational data and mechanistic studies.
So the science isn't settled on one perfect number for anti-aging benefits.
Not at all. The listener needs to understand this ambiguity exists. The truly optimal level, especially in the context of maximizing healthy aging, is still very much an active area of research and debate. There's no single magic number agreed upon by everyone.
Okay. And this uncertainty leads us to perhaps the most critical caution, the risks of excessive intake. You mentioned D is fat soluble. That means taking too much is a real danger, unlike with vitamin C where you just pee out the excess.
This is the absolute non-negotiable safety warning. Because vitamin D is fat soluble, your body can't easily get rid of large excesses. It accumulates primarily in your fat tissues. Consistently taking very high doses, especially exceeding the established tolerable upper limit, UL, which is generally set at 4,000 IUs per day for adults without medical supervision, is genuinely dangerous.
Why? What happens?
It can lead to vitamin D toxicity, and the main consequence of that toxicity is hypercalcemia.
Hypercalcemia.
Too much calcium, right. Exactly. Abnormally high levels of calcium circulating in your blood. The excess D forces your gut to absorb way too much calcium from your food.
And this isn't just like mild indigestion. What are the actual serious symptoms someone needs to watch out for if they mistakenly megadose?
No, it's not mild at all. Early symptoms might be nausea, vomiting, constipation, weakness, maybe confusion. But as calcium levels climb higher, that excess calcium starts getting deposited in soft tissues where it doesn't belong. This can cause serious kidney problems, kidney stones, calcification of the kidney tissue itself, nephrocalcinosis, potentially leading to irreversible kidney damage or failure.
Wow, okay.
And furthermore, severe hypercalcemia can directly interfere with the heart's electrical system, leading to dangerous heart rhythm abnormalities, arrhythmias, that could require emergency medical treatment. It can be life-threatening in extreme cases.
So the message is crystal clear. More is definitely not always better, and unsupervised high doses are risky.
Extremely risky. Testing, sticking within recommended ranges, and medical supervision for higher doses are absolutely paramount.
And one final layer of complexity. Even if people follow the guidelines, there's this issue of variability in response. Not everyone reacts the same way.
That's a vital point, and it really highlights why personalized approaches are likely the future here. Individual outcomes from the same dose of vitamin D can vary significantly.
That's that.
Several factors are at play. Are individual genetics variations in the VDR gene itself, or genes involved in D metabolism, can make a big difference. Also, your baseline diet, especially calcium and fat intake, your geographic location and how much actual sun exposure you get, your skin pigmentation, your age, your body weight, D gets sequestered in fat tissue, and the health of your gut, affecting absorption. All these things influence how efficiently your body makes, absorbs, converts, and ultimately uses vitamin D.
So a standard dose might work perfectly for one person, but barely move the needle for someone else.
Precisely. It means a one-size-fits-all recommendation often falls short, which underscores, yet again, the importance of testing to see how your body is actually responding.
Okay, given all that complexity, the potential benefits, but also the very real risks and uncertainties, let's shift into practical, actionable advice based on the evidence. For you, the listener, if you're interested in optimizing your vitamin D status specifically for healthy aging, where is the absolute best place to start?
Unanimously, across all the reliable sources, the single most important first step is testing, period. You absolutely need to get your vitamin D levels checked by a healthcare professional. The standard blood test is called the 25-hydroxy-vitamin D test, sometimes written as 25-OHD.
Why is that baseline test so critical?
Because you simply cannot know where you stand otherwise. You don't know if you're deficient, insufficient, or already have adequate levels. Without that baseline measurement, any supplementation strategy is just guesswork. The test result is what guides the entire approach, whether you need to supplement at all, and if so, at what dosage.
Okay, step one, get tested. Now, let's try to nail down some of those dosage numbers again, based on general guidelines, acknowledging the ambiguity we discussed.
Right. So for general health in the broad population, the recommended dietary allowance, RDA, is typically set at 600 to 800 international units, IU, per day for most adults up to age 70. For adults over 70, the recommendation often bumps up slightly, maybe to 800 IU, because older skin is less efficient at making D from sunlight, and there might be absorption issues too.
And that's just for maintaining general health, assuming you're not deficient. What if that crucial blood test comes back showing actual deficiencies, say, below 20 ngml?
Then the protocol changes significantly, and this absolutely needs to be managed and monitored by a doctor. You're moving into therapeutic dosing. Doses used to correct a diagnosed deficiency are much higher than the RDA. They often range from 1,000 IU up to 4,000 IU per day. In some cases of severe deficiency, doctors might even prescribe short bursts of very high doses, like 5,000, 10,000 IU, or even 50,000 IU weekly or monthly for a limited time to rapidly boost levels.
The super high doses are short-term and supervised.
Absolutely short-term and must be medically supervised with follow-up testing. We have to keep hammering on the tolerable upper limit, UL, for ongoing daily intake for adults, which is 4,000 IUs per day.
That's the safe ceiling for long-term use without specific medical oversight.
Correct. Consistently going above 4,000 IU daily significantly increases the risk of toxicity over time, unless your doctor has specifically recommended it based on your levels and is monitoring you closely.
Now, what about those specific groups you mentioned earlier who might need to pay extra attention or potentially need higher doses, even if their tests aren't severely low?
Yes, there are several key groups. First, older adults, just due to the aging process affecting synthesis and maybe lifestyle factors like less time outdoors. Second, people with naturally darker skin pigmentation. Melanin is a fantastic natural sunblock, but it significantly reduces the skin's ability to produce vitamin D from UVB rays. So individuals with darker skin often need much more sun exposure or higher supplemental intake to reach the same D levels as fair-skinned individuals.
Okay, older adults, darker skin.
Third, anyone with genuinely limited sun exposure. Maybe due to living in northern latitudes with long winters, working indoors consistently, covering up for religious or cultural reasons, or being housebound due to illness. And fourth, people with certain medical conditions. Obesity is a big one as D gets trapped in fat cells, making it less available to the body. Also, conditions that cause fat malabsorption like Crohn's disease, celiac disease, or previous gastric bypass surgery can severely impair vitamin D absorption from food or supplements.
So these groups often need to be more proactive and might require doses towards the higher end of the normal range, or definitely need supplementation if sun exposure is minimal.
Correct. They often require careful assessment and potentially higher medically guided supplementation strategies.
Okay, shifting to the logistics of taking supplements. Are all D supplements the same? And does how you take it matter?
Yeah, the best practices seem pretty clear from the sources. When you're choosing a supplement, you generally want to opt for vitamin D3, cholecalciferol.
That's right. D3 is the form our bodies naturally produce from sunlight. And the research generally shows it's more effective and bioavailable, meaning easier for the body to use at raising and maintaining blood levels compared to vitamin D2, ergocalciferol, which often comes from plant sources or fortified foods. So look for D3 on the label.
Good advice.
And because it's fat-soluble, the timing and context matter for absorption.
Absolutely. Taking your vitamin D3 supplement with a meal that contains some healthy fats can significantly boost how much your body absorbs.
So not on an empty stomach. Take it with food containing fats like
Things like avocado, nuts, seeds, eggs, fatty fish, or even just the olive oil used in cooking or on a salad. Having some fat present in the gut helps dissolve the D3 and allows it to be absorbed more effectively.
simple tip, but probably makes a real difference. And consistency is key too, presumably.
Crucial. Like any supplement intended for long-term benefit, you need to integrate it into your regular daily routine to maintain stable blood levels. Taking it sporadically won't provide the consistent background support you're aiming for.
Makes sense. Now, stepping back to the bigger picture.
Yes, it's so important to stress the context. Vitamin D, even at optimal levels, is not a standalone solution for healthy aging. It's not a magic pill that lets you ignore everything else. Its benefits are really maximized when it's part of a truly holistic, healthy lifestyle. Meaning a balanced, nutrient-dense diet rich in other important cofactors like magnesium and especially vitamin K2, which works synergistically with D to direct calcium into bones and away from arteries. It also means regular physical activity, including both resistance training for muscle and bone and aerobic exercise for cardiovascular health. Getting adequate, high-quality sleep is critical. Managing chronic stress is huge. And, of course, avoiding smoking.
So D helps a healthy lifestyle work even better, but it doesn't replace it.
Precisely. It amplifies the benefits. It doesn't substitute for the foundations. And let's just quickly revisit sunlight. Sensible sun exposure is still the most natural way to get vitamin D. We're talking brief periods of unprotected exposure, maybe 10 to 30 minutes, depending heavily on your skin type, the time of day, the season, and your latitude, ideally around midday when UVB rays are strongest.
But always balancing that with skin cancer risk.
Always. That balance is crucial. For many people in modern life, especially those concerned about skin aging and cancer risk, relying solely on sun exposure to maintain optimal D levels year-round is often impractical or unsafe. That's why supplementation, guided by testing, becomes the more reliable and controllable strategy for most.
And for anyone on higher doses or with those risk factors we discussed, regular follow-up testing is important.
Absolutely essential. If you're taking doses near or above the UL or managing a deficiency, regular monitoring of your blood levels, and sometimes calcium levels too, is necessary to ensure you're hitting the target range safely and effectively without overshooting into toxicity. #, outtrip.
Okay, this has been a really comprehensive deep dive. It feels like we've fundamentally reframed how we should think about vitamin D. To quickly recap the major takeaways, we now understand D's true identity isn't just vitamin, but a powerful prohormone, thanks to that widespread vitamin D receptor, VDR, giving it keys to genetic switches all over the body.
Yeah.
That deep influence gives it a vital role as an immune modulator, crucially helping to fight that chronic, low-grade inflammaging, which we identified as probably the main engine driving so many age-related diseases. And while we have to be cautious about definitive proof, those potential links to preserving cognitive health and maintaining physical independence through bone and muscle support are what make optimizing D status feel so relevant for quality of life as we age.
I think that captures it well. And the final concluding message, drawing directly from the most rigorous sources we looked at, has to be clear. Vitamin D is, without question, a vital nutrient. It's a significant contributor to healthy aging, particularly by helping mitigate some of those common, predictable declines in muscle, bone, and immune function. But, and this is the crucial super reality check, it is not a magic bullet. It doesn't stop aging. Leveraging its considerable power requires respecting its complexity, really understanding its mechanisms, and most importantly, ensuring you achieve and maintain optimal, safe levels. And that means professional guidance, blood testing, and always, always integrating it into a broader, comprehensive, healthy lifestyle strategy.
Perfectly put. Okay, now for our final provocative thought for you, the listener, to ponder after we sign off. Something building on that challenge of individual variability we discussed, since this deep dive made it so clear that how your body responds to vitamin D supplementation can vary wildly because of your unique genetics, your metabolism, your lifestyle. How might the future of personalized medicine, maybe using advanced tools like genetic testing for VDR variants or detailed metabolic profiling, help us finally move beyond these general population guidelines? Could we one day pinpoint the exact, truly optimal vitamin D level needed, not just for most people, but for your unique personalized path to maximizing your healthy aging potential? Think about that intersection. Personalized science meeting longevity. Where might that take us? That's something to chew on as the research continues to unfold.